Okay, so today's notes are going to be about a rule that we call chain rule. And this is probably one of the single hardest topics of all of AP Calculus, but it's so important. So I would highly recommend when you finish this video to go back and maybe even just rewatch it one more time, double speed, and just really try to get the hang of this rule. It's a pretty complicated rule. It's probably one of the more complicated rules of AP Calculus. So we're going to kind of illustrate the same thing we did the last few days and start off by showing how would we do this, expanding it with polynomial form. And so to save us a little bit of time, I went ahead and did that off video. And so essentially we, cube it. So we write 2x plus 3 three times. Then I multiplied the first two together using the shortcut because it's something squared. 4x squared plus 12x plus 9 times 2x plus 3. You could also do box method if that works for you. And here I kind of took this and wrote it kind of doing the long process, but just lining everything up. And so we get f of x equals 8x cubed plus 36x squared plus 54x plus 27. And now we can just do regular old power rule, right? Take the derivative with power rule. Power rule is just our normal rule for our derivatives. So 24x squared plus 72x plus 54. And so that's our answer for our derivative. Okay, so Leibniz was the first mathematician to actually write out and develop chain rule. And chain rule, like I said, it's a little bit complicated, but we're going to write it as if f of x equals g of h of x. And it's a little bit weird, but we'll talk about this. Then f prime of x equals g prime of h of x times h prime of x. Okay, and it's a little bit tricky, but what we really need to understand is this word composite functions, or composition. And so composite functions are essentially any function that has an inside term and an outside term. So up here, right, f of x essentially is 2x plus 3 cubed, but kind of what's happening is if we kind of try to put in that g of h of x business, it's essentially that g of x is going to be whatever's, change that whole thing to just like that box, change that to an x. So g of x is x cubed. That's our outside, is something being cubed. And h of x is 2x plus 3. So what we're doing is we're taking this 2x plus 3, and when we put it in for x, we get f of x. We get this whole 2x plus 3 cubed. And that's what we mean by composition. Now, I know that can be weird, and I don't ever want you to have to worry about doing it that way. And I like to do it with boxes. Okay, I think Leibniz or Newton would be very upset with me if I did it with boxes in front of them, but it really works well for me. And so what I kind of do is I take my inside and I kind of say if f of x, essentially is, g of some box, right? Then f prime of x is going to equal g prime of my box times the derivative of my box. And I write it this way instead of box prime, but you could write it box prime. So I kind of do that, and I'll show you, I do it this inside out method, which is, what a lot of AP teachers will do. But I like to just kind of put a box around anything that's unnormal, right? So for example, we already know, like back from, last chapter, if we had y equals x cubed, y prime is nice and easy, it's 3x squared. But now we don't have x cubed, we have basically what we think of as we have y equals box cubed. So the derivative is going to be 3 box squared, but then we need to multiply by the derivative of the box. That's what I mean when I kind of showed this formula here, right? Is what would be the derivative of x cubed would be 3x squared, but then we need to multiply by that box, the derivative of the box. So that's, one way to think about it. Now, I never actually write any of that out. When I'm doing it, I just kind of, in my head, have done chain rule so many times, and you'll get better, so you can write less and less. But we really want to think what's the outermost, okay? We're almost doing PEMDAS backwards, right? With PEMDAS, we would start with the inside, 2x plus 3. Well, with chain rule, we're starting with the outside. So what's the outside most kind of function is that cubed, being cubed. So for f prime of x, we're going to start off with that cube. If we had anything, some box cubed, what would be the derivative of box cubed, of anything cubed would be 3 times that box squared. Now we're not going to write the box, we're going to put back in 2x plus 3, right? But that's squared. And then once we have that, now I cancel out my 3, I cancel out that outside thing, and I do the derivative of the next part. Well, what's the derivative of 2x plus 3 is 2. And I always put this derivative in parentheses because sometimes you're going to need that. Sometimes you're going to have two, basically like you have 2 items in that parentheses and they're going to need to distribute. So always add that parentheses. Now we can just bring the 2 and the 3, they're like terms, right? 2 times 3 are like terms. You can't multiply with anything in here because it's inside a parentheses that's being squared, right? But you can multiply the outside terms. So 6 times 2x plus 3 squared. Now, that doesn't quite look like what we have up here, but, just to prove it really quickly, we could expand it. So if we expanded it using the shortcut, we get 6 times 4x squared plus 12x plus 9, distribute the 6, and now they do match up. So the nice thing about chain rule actually is a lot of times it will put it into its most factored form for you, which is nice. Okay, so let's try one on our own. Find the slope of the normal line, and again, slope of the normal line. So we've done this a few times, but anytime we have something like that, step 1 would be to find f prime of x. Step 2 is going to be to plug in. So find f prime of our number that we want. In this case, that would be 3 pi over 4. So plug in 3 pi over 4. And then step 3, since it's a normal line, would be to do the opposite reciprocal. So anytime we have sine, I do want us to be careful, okay? Is mathematicians are lazy and they write sine squared of theta. If you put this into a calculator, you're going to get a context error. And even when you try to do this by hand with chain rule, it can be confusing. The better way to write this is to write sine of theta squared. So anytime you guys see sine squared of theta, just rewrite it as sine of theta squared in a parentheses like that. So I'm going to do that first before I actually even try to think about chain rule. So sine of theta squared. So this is what I was saying. We could easily do x squared, but if it's not x squared, if it's anything else, just kind of draw a box around it and think chain rule. Okay, so I'm going to think chain rule. So f prime of theta, what do we do on chain rule? We do our outside. What would be the derivative of box squared? What would be the derivative of something squared? Would be 2 times my box, right? Like the derivative of x squared would be 2x. If you ever are like confused about what it might be, always just think back to that. So 2 times the box, but then now times, I cross that out, times the derivative of the box. So times the derivative of the sine theta would be cosine theta. So you get f prime of theta equals 2 sine theta cosine theta. Now that's not our answer. That was for f prime of theta. Now, that was step 1. Now step 2 would be to plug in 3 pi over 4. So 3 pi over 4, if we think on our unit circle, right, 1 less, 3 is 1 less than 4, so we're in that second quadrant. And pi over 4 is always square root of 2 over 2. So this is going to be times square root of 2 over 2. And then times negative square root of 2 over 2 because we're in that second quadrant where sine is positive but cosine is negative. Okay, and now the square roots, square root of 2, basically square root of 2 times square root of 2 is square root of 4. Or you can think of the square roots canceling out, right? The square root of 4 is back to 2. So this is going to give me 2 times, I'm going to multiply across here. So this is going to be negative 2 over 4. Right? And then if I multiply negative 4 over 4, it gives us negative 1. So we have negative 1. Now, that was step 2. Now, our third step is going to be to do the opposite reciprocal. So the opposite reciprocal of negative 1 is just positive 1. Right? You flip the sign, and then when you flip 1, the reciprocal of 1 is just itself. So that's our slope of our normal line. Okay, so we're going to jump into some examples. And essentially every single time we do these, you just want to think if it's something kind of looking complicated, like, right, just box it. What would be the derivative of x cubed? Would be 3x squared. So the derivative of box cubed is 3. And if you want to write that, you could even write that 3 box squared times the derivative of the box. You don't have to write that, but if it's going to help you, go ahead and write it. So this is 3 times 3x squared plus 2 squared times 6x. And again, the 6x is not being squared, so it's a like term with the 3. When we're multiplying, they're like terms. 18x times 3x squared plus 2 squared. Okay. Next we have a square root, and this is where, if you want to, you can use that rule that we learned on for the product rule lesson, which was that if we have square root of x, then the derivative is 1 over 2 squared root of x. So what that means here is if we kind of box that, well, if we had g of x was the square root of box, then our g prime of x would be 1 over 2 square root of box times the derivative of the box. So that's the formula we're going to be using. Now, can you rewrite this as 2x plus 5 to the half and do it that way? Absolutely. But I like using a shortcut whenever I can. So in this case, right, we're going to say 1 over 2 square root of box, and instead of box, it's 2x plus 5, times the derivative of 2x plus 5 is just 2. Okay, now, be careful about what you cancel. You can only cancel things that are outside of the square root with things that are outside of the square root. So I've seen a lot of people try to do that. That does not work. But you can cancel the ones outside of the square root. So that gives us g prime of x equals 1 over the square root of 2x plus 5. That does work. And there's our answer. Okay. Our next one. Now, this rule, I want to be careful about this rule. A few of you guys on Monday or Tuesday, I think it was on Tuesday, were trying to apply this rule when it wasn't a square root of x. This rule only works for a square root of x. So when we get to numbers essentially like 3 and 4 here, these are cube roots of x, right? When we have cube roots of x, it does not work. That shortcut does not work. So we have to rewrite it. And we do want to be very careful. I know there was a little bit of confusion here. But here, we don't write this in here. It's a 2. That's when that rule would work for a square root. But if you see it written, then it's a 3. But to rewrite this, there's no power here. But technically, this is the first power. So this would be 9 to the half power. That's saying the square root of 9. This guy would be saying 9 to the, again, there's nothing written there, but it's a 1, so it'd be to the 1/3 power, right? So just being careful about that and how we rewrite these. So in this case, the number that is inside, the exponent that is inside our radical kind of hugging it is the x. That's going to go in the numerator of our fraction. So when we rewrite this, we get h of x equals to x plus 2 to the power of 2 over 3, right? The 3 goes in the denominator. Now, we could do x to the 2/3 power, right? We could take that derivative. But this is not x to the 2/3 power, it's x plus 2 to the 2/3 power. So we're going to kind of box that. And we're going to say, okay, h prime of x equals 2/3 times our box, x plus 2. Now, when we subtract 1, that's like saying minus 3 over 3. So to the negative 1/3 power. Now, I kind of cancel that out, and I say now I need to multiply by the derivative of the box, which is just 1. So this becomes 2/3. And, we can put the x plus 2 in the denominator, x plus 2 to the 1/3 power. And so that's a perfectly fine answer. Honestly, this would have been a perfectly fine answer. Or if you want to put it back into radical form, right, it'll be the cube root of just x plus 2 to the first power, so you don't have to write to the first power. So really, any of these 3 answers would be fine. You'll get full credit for any of those 3 answers. Okay. Next one. This 5 throws a lot of people off. Don't let it throw you off. Anytime you have a coefficient, it just stays as a coefficient. So this is 5. Now, parentheses, x squared plus 2x. Now, you got to be careful about this. A lot of people try to do x to the 2/3 power here. It's not, because the entire thing is to the first power. So it's to the 1/3 power. That's how we need to write this. You have to group the entire radical together in a parentheses. So there was no exponent, like in this one, there was an exponent with the 2, which is why we were able to put the 2 on top. But here there's nothing, so it's just to the first power. Okay, and then the 3 goes into the denominator. That's probably going to be the hardest part for a lot of you guys on these. We'll be rewriting these radicals. So now f prime of x, right? Just kind of think, okay, this is my box, is this x squared plus 2x. So when we take the derivative, it's just like if we did it earlier. What would be the derivative of 5x to the 1/3? We just do 5 times 1/3 would be 5/3 x to the negative 2/3. Now it's the same, but with a box. So 5 times, and again, I don't always write it this way, but if it's going to help you, go ahead and write it as a box. 5 box to the negative 2/3 times the derivative of the box. If that's going to help you, then write that out first. If it's not really helping you, then you don't have to write it. So this is 5, times 1/3 would have been 5/3. 5/3, well, I can't write. 5/3, right, because 5 times 1/3 times x squared plus 2x. And we subtract 1, right, minus 3 over 3 gives us to the negative 2/3 power. Now, I kind of cross that out, and then times. Now, this is where I said this is the whole reason I've been using that parentheses, is 2x plus 2. If you do not have that parentheses there, you will get this question wrong. You need to have the parentheses around the 2x plus 2. Now, this is perfect, full credit. Okay. If you want to take it a step further, we can move the the x squared plus 2x to the denominator. And then times 2x plus 2, you can actually put that in the numerator. And so this would also get full credit. And if you wanted to put it in radical form, you can do that as well. So 5 times 2x plus 2. You'd even multiply out the numerator and make it 10x plus 10. 3 to the now cube root, because it's the 3 is going to, the bottom, the denominator is going to go to the root part. And in parentheses, x squared plus 2x squared. So that would also get full credit. So any of those 3 would get full credit. Okay, next one, cosine squared of 3x. This is where these two questions are going to get hard, because these two questions have a double chain rule. So you basically have to do chain rule twice. And that happens, you can do chain rule twice, sometimes you do it 3 times, you can do it even more times. So the first thing is, anytime I see this squared, always just rewrite it. It's going to help you out. Rewrite this as cosine of 3x squared. Now, the reason this one's tricky is, and before I do this question, I want to just kind of jump down here and just think about, what about just f of x equals cosine of 3x? Just really easy, cosine of 3x. Okay, what would the derivative be? Well, this is chain rule, because we can't do the derivative of cosine of 3x. That wasn't something we memorized. We memorized the cosine of x. So what was the derivative of cosine of x? Was negative sine of x. But instead of x, we're going to put a box. And when we have a box, we have to do chain rule on the box. So this gives us negative sine of 3x times 3. So that's just something to watch out for. That would have been chain rule. So this is why up here, you're going to see that we're going to have 2 chain rules. Because first, we have like our box squared. Okay, what would be the derivative of box squared? Would be, and this is why I said we really want to make sure we're working from the outside in, and this is why I cross out is for these questions. So it'd be 2 times our box, cosine of 3x, to the first power. So now I'm going to get rid of that. Now, what's the derivative of cosine of 3x? What's the next most outside part? The next most outside part is our cosine. So now we have cosine of 3x. So we're going to do times, now what's the derivative of cosine? Is negative sine of that box of 3x. I'm going to cross out the cosine. Now, what's the derivative of 3x? Is 3. So times say the derivative of the box inside times 3. Now, be very careful when you try to combine like terms. I've seen a lot of people try to do, 3x times 3 is negative 9x. That does not work. Okay? They didn't use parentheses here, but there is a parentheses right there. It's cosine of 3x, and it's sine of 3x. The 3 is not inside of the sign. The 3 is a coefficient. And there's one more coefficient that we don't really notice. It's negative 1. So 2 times negative 1 times 3, our overall coefficient is negative 6. Cosine of 3x times sine of 3x. We can write it this way, or if you want to, add in parentheses around your 3x, make it a little cleaner, and that works too. Some textbooks will even write the sine of 3x first. They'll just kind of change the order. You'll see that a lot of textbooks like to write sine first always. It's just kind of how you write x squared first, and then x. They'll write sine first, but you don't have to. Anyways, next one, same thing. Our first step should always be, whenever we see this squared with trig, is to rewrite it. So this is going to be sine of 2x plus 1, all in a second big parentheses squared. And this one's nice because we have the double parentheses. You could have added this one. You could have put a parentheses. You might have made it a little nicer. So h prime of x, right? What's our very outside is the squared. So our very outside is the squared. So I'm going to go 2 times sine everything inside is staying the same. This is going to be a pattern. Everything inside staying the same. Now, it's really to the first power. You don't have to write the first power, but I'm going to cross out the 2, right? That was my first initial box. Now, what's the next outside is the sine. What's the derivative of sine of a box? Would be cosine of our box. But now we have a new little box, 2x plus 1. So cosine of 2x plus 1. And then finally, now I cross out the sine. What's the derivative of 2x plus 1? Would be times 2. So the 2's are my coefficients. So it becomes 4 sine of 2x plus 1 times cosine of 2x plus 1. So I know these are weird, but the more we see about them, like the more we practice them, the better we're going to get at them. So this is essentially the basics of chain rule. I do